Okay, page 1096, container types and behavior. Once you have recognized that a location or occupancy, you may have hazardous materials, the presence of certain storage vessels, tanks, containers, packages, or vehicles can confirm their presence. Containers can provide useful information about materials inside, so it is important for you to recognize the shapes of different containers and packaging in which hazardous materials are stored and transported. Depending on the container and packaging type, hazardous material behavior may vary. Some basic generalizations may be made about a hazmat incident based on the type of container involved. Okay, let's get into, in addition to the container shapes, first responders should be familiar with the basic concepts of pressure and their measurements. So here's just some of the basic pressures and measurements. So pounds per square inch, that is a common measurement in the English customary system. Atmospheric pressure, which we said is 14.7 psi, that is the force exerted by the weight of the atmosphere at the surface of the Earth. And then pressure at gauge, unit of pressure relative to the surrounding atmosphere. Customary system is pounds per square inch gauge. All right, containers by transport mode and capacity. Hazmat containers are sometimes classified according to their transport mode. Now, the department that is actually classifying them, and you need to know this, is the Department of Transportation, DOT, and in Texas it would be TxDOT, Texas Department of Transportation. That is who regulates the hazardous materials in transport mode. You need to write that down, DOT. These transport modes could be highway cargo trucks, rail cars, intermodal containers. These containers may be classified by capacity. Need to know that, by capacity. Let's talk about what's called bulk packaging. Packaging other than a vessel, ship, or barge in which materials are loaded with no intermittent form of containment. These can include cargo tanks, rail cars, portable tanks, intermediate bulk containers, and intermodal containers. Criteria, we need to know this. Bulk containers, this is for bulk containers. Maximum capacity greater than 119 gallons for a fluid or a liquid. Maximum net mass is greater than 882 pounds. Or a water capacity is 1,001 pounds or greater as a receptacle for a gas. Need to know that is for bulk packaging. Know that. Non-bulk packaging. Non-bulk packaging. Smaller than the minimum criteria established for bulk packaging. We need to know what some of the non-bulk packaging would be. That would be a drum, a box, a carboy, or a bag. So if it's less than the criteria for the bulk capacity, it would be a non-bulk capacity. So they are smaller than the minimum criteria for bulk. Okay. Let's go over to page 1101. Real quick, I've got some things marked here on page 1100. Look up at that figure 24, I believe it's 78. And again, it's given the bulk packaging, large quantities of liquid solid gas to be shipped. And one of the things we had was bulk versus non-bulk on the bulk packaging greater than, and it was the same numbers I just gave you. So definitely make sure you look over that. Some of the containers by name on table 24.6. For the highway, we're going to be dealing with cargo trucks, for the rail cars, for the water, vessels, and we also have intermodal containers. So, highway cargo trucks, highway vehicles that transport hazardous materials that include a cargo tank, you need to know this, cargo tanks, dry bulk containers, compressed gas containers, and mixed load containers. You need to know that. Transport all types of hazardous material in a wide range of quantities. Depending on the type and quantity of the hazardous material, these vehicles may have DOT or TC placards. Okay. Now for cargo trucks, they are recognizable because they have construction features, fittings, attachments, or shapes characterized by their uses. I mentioned earlier that you're going to have to look at the shapes of these containers and you're going to have to know what particular type of cargo tank that this might be. Cargo tank trucks are commonly transported, know this, they commonly transport bulk amounts of hazardous materials on the roadway. That would be cargo tank trucks on the roadway. If you look down on page 1101 and you see a DOT specifications, let me slide down. These specifications the minimum tank construction material thickness, required safety features, maximum allowable working pressures. That was something that you would find on these specifications. Cargo tank specifications and nameplates provide information about the standards in which the container was built, usually found on the roadside or the driver's side of the vehicle. Make sure you know that. Specification, these plates are on the driver's side of the vehicle near the rear of the dolly leg. Two specifications in use are the motor carrier MC and the DOT's TC standards. So what we need to know, look on page 1101, figure 2481, know that the manufacturer specification plates, need to know this, provide information about the tank's pressure, capacity, and number of compartments. Make sure you know that, highlight that. Non-spec containers. Tanks not constructed to meet one of the common MC or DOT specifications may haul non-regulated hazardous materials if the tank was designed for a specific purpose and exempted from the DOT TC requirements. Non-hazardous materials may be hauled in either non-spec cargo tank trucks or cargo tank trucks that meet a designated specification. So what we need to know is that non-hazardous materials, need to know this, may be hauled in either what's called a non-spec, non-specification cargo tank trucks or cargo tank trucks that meet a designated specification. Make sure you know that. Rail cars. Rail cars, they carry the bulk of the hazardous material transported by rail. Some have the capacities of 4,000 to 34,000 gallons. Because these cars carry large quantities, an accidental release of gases or liquids can cause many difficulties for responders. By recognizing distinctive railroad cars, first responders may begin the identification process from the greatest possible distance. The type of car gives clues as to what material may be within, the material's weight and volume. Tank cars are divided into following three main categories. You have low-pressure tank cars, also known as general service tank cars, pressurized tank cars, and cryogenic. Remember, cryogenic is going to be anything that's carrying the liquids that are minus 130 degrees Fahrenheit. Now, one of the biggest difference, if you look at your handout, between low-pressure tank cars and pressure tank cars. if you look at the top of the tank, on the top of the tank, if you can see any sort of valves or fittings, if I can see them, then I know that it is a low pressure tank. If there is a housing with a cover that's bolted down, then it is a pressurized tank car. So you may get a symbol on a test, and you have to look at the top, and if you can see things that look like little valves sticking up, little hand valves, hand wheels, you would know that is a non-pressurized container. If you see something that has a housing at the top, then you would know that that is a housing that's bolted down, that is a pressurized car. Otherwise, they look pretty much the same. You do need to know also that low pressure tanks are known as general service tank cars. And they are also known, low pressure are also known as non-pressure. Make sure you highlight that. Responders can receive valuable information from markings on rail cars about its contents. Some of these things are reporting marks, capacity stenciling, and specification markings. So we need to know this. These are the ways that we receive information: report marks, capacity stenciling, specification markings. You're going to see an example of this over on 1104, but we'll get there in just a second. Let's talk about ERG provides a key to these markings in the rail car identification chart, and more information is provided in sections that follow. So let's go down to the report markings. Report markings. Tank cars are marked with unique sets of reporting marks. They are also called initials and numbers. They may be used to obtain information about the car's contents from the railroad, computer, the shipper, Chemtrek, Canutech, or Sitq. Should match the initials and numbers provided by the shipping papers, and they're stenciled on both sides. Capacity stencils. You need to know that the capacity stencils, this shows the volume. Highlight that. Shows the volume of the tank car. That volume is going to be in gallons. It's stenciled on both sides of the car. Capacity in pounds, stencils on the side of the car under the car's reporting marks. Specification markings. Indicates the standards to which a tank car was built, so you need to know that. Specification markings is which is when the car was built, stenciled on both sides of the tank. When facing the side of the car, the marking will be to the right, opposite from the reporting marks. First responders can also get specification information from the railroad, shipper, car owner, or the Association of American Railroads. Add this when we talk about stencil. Add a stenciled name on its side is a designated car. A stenciled name on its side is a dedicated car. Make sure you add that, write it down. So let's look on page 1104 now. Specification markings. You'll notice that right there, the approving authority, Department of Transportation, the DOT. We need to know this, the class number. The class number. If it's 1111 or 111, then that would be a non-pressure rail car. 111 would be a non-pressure rail car. The tank pressure would be 60. The material that is constructed is aluminum, Al. Gives you the weld type and the fittings or the material lining. So just know DOT is the approving authority. The class number, if it's a 111, would be a non-pressurized car. And the symbol, if it was an A, that would be the separator. And then you have the pressure, which would be 60, and the type it's made of. Intermodal containers. Intermodal containers. These are shipping freight type containers used interchangeably in multiple modes of shipping. And this could be anywhere from rail, highway, or ships. Two main categories. Freight containers transport a wide range of products. And they could come in a variety of sizes. Several common types of freight containers are dry van, refrigerated, and any sort of open top. Now the main thing I want you to know about these intermodal containers, and let's go to page 1106, is that the tank containers, also called intermodal tanks, have three general classifications. You have pressurized intermodal containers, specialized intermodal containers such as cryogenic, and low pressure. All right, so on 1106, table 24-7, you must know this. You must know that if it is a IM 101, IM 101, or an IM 102, those are non-pressure intermodal tanks. Non-pressure intermodal tanks. IM 101 and IM 102. The piping and the fittings, if it is non-pressure, the piping and the fittings will be exposed on the outside of the tank. The pipings and the fittings will be exposed on the outside of the tank. Now, if you look over on table 24B, I already gave you 101 and 102 are non-pressurized. Now, in pressurized intermodal tanks, you see something that's called a Spec 51. A Spec 51. The Spec 51, if you want to add that to pressurized intermodal tanks, Spec 51 pressurized intermodal tanks, all the valves and the fittings will be concealed. Anything pressurized will be concealed. Okay, and the last one would be the cryogenic, which we already talked about that in the other tanks. Now the capacity, you do need to look over on table 24.8 at the capacity. The capacity for IM 101 and 102, IM 101, 5,000 to 6,300, 102 is 5,000 to 6,300, so it's the name. Both of those are non-pressure. Now the capacity for Spec 51, which is pressurized, is anywhere from 4,000 to 5,500, 4,500 to 5,500 as far as a capacity. Now let's look at the pressures. The pressures, 24.4 to 100 psi for IM 101, 14 to 25.4 for an IM 102. Now, Spec 51, 100 to 500 psi, that is pressurized. So we need to add this. We need to look at the bottom of 1106, pressurized containers. Know this. Know that pressurized containers have the potential to release a great deal of energy if involved in an incident. Make sure you know that. So IM 101, 102, non-pressurized. If you look at design pressures, you might want to need to know those. Spec 51, pressurized, and make sure you know those pressures. Okay, 1109. On 1109, pressurized container examples are provided. Clues to the pressure containers. Here's some clues. Make sure you know this. Clues to a pressure container. Rounded spherical ends. So these both ends are going to be rounded. Both ends rounded. Bolted manway covers. Rounded ends, bolted manway covers. So if we look at 1109, if we look at figure 2496, You see those containers? They are rounded. If you look at the other containers, both ends are going to be rounded, bolted down containers. They will have also, know this, pressure relief valves. So highlight rounded ends, bolted manway covers, pressure relief valves. Common stressors. Common stressors are going to be thermal, which could be heat, chemical, could be a corrosive, or mechanical, which could cause mechanical stress, container fittings, some sort of damage to the outer parts of the wall. I'm on page 1112 now. Just going to kind of read this real quick. Pressure containers can experience any type of breach, although releases from pressure relief valves or damaged fittings are the most common. We already said this, and I'm just going to mention one more time. Runaway cracking associated with blevies. Pressure containers release rapidly expanding gases or liquids that quickly evaporate and expand to gases and vapors. Common dispersion patterns from the pressure containers. These are the same things we went over earlier. So just real quick, I'm going to go over it again. Hemispheric pattern, that would be known with the BLEVE. Make sure you highlight that. Hemispheric pattern of BLEVE. We already said you have to know the difference. You have to be able to look at a picture and say that is a cloud. And you have to know what a cloud pattern looks like. A plume, a cone. Page 1113, bulk facility pressure tanks. Make sure you highlight this. Fixed facility pressure tanks have pressures of 15 psi or greater. Example of pressure containers include horizontal or spherical pressure tanks or pressure vessels. Typically release their products or gases and vapors during rapid relief incidents or events, slow leaks from valves and fittings, or violent ruptures. May contain a variety of flammable, toxic, or corrosive gases, especially dangerous when subjected to heating or fire because they can blend. Let's go down to high pressure tanks. High pressure tanks. Need to know this, also known as MC331s. MC331s, high pressure. You must know this, have pressures typically between 100 to 500 psi. 100 to 500 psi. Have pressure cargo tanks and have a single steel compartment. Can transport anything from liquefied gases, high pressure tanks, pressure liquids, hazardous materials. High pressure bobtail tanks are used for local delivery. Any of those things might be considered or high pressure tanks. MC331. Anywhere from 3,000 to 11,000 gallons with pressures of 100 to 500. Make sure you know that. Some of the features I want you to know. High pressure, 331, bolted manway covers. Here's another one, white or other reflective paint scheme. White or other, make sure you highlight that. Could have a guard cage around the bottom. Emergency shutoffs, know this. Emergency shutoffs located in the left front and right rear. Left front, right rear. A lot of times the emergency shutoff behind the driver. Write that down, behind the driver. Left front and right rear, behind the driver. Permanent markings such as flammable gas, compressed gas, shipping names. Look on page 1114 and look at figure 24104. 24104. Make sure you know this. The initial evacuation distance for high pressure tanks. 1 mile. Make sure you know that. Highlight that. 1 mile. Initial evacuation distance for high pressure tanks, 1 mile. Highlight that. I'm on page 1116. Look up at the top, figure 24.110. Pressurized tank cars have fittings protected with a single housing at the top of the tank. So if you notice, and there's a good description of a pressurized rail car, you can tell by looking at a distance there, if it has a housing and has a bolted down cover, that is a pressurized tank. But if you can see the fittings by looking at it from the side and you don't see that housing, then it would be non-pressure. I'm just kind of moving through here. Compressed gas tube tanks, just real quick, I'll go over it. These are individual steel cylinders stacked and mounted together. Typical pressures in the tubes, anywhere from 24 to 5,000 psi. Each cylinder typically has an overpressure device, and they can carry multiple different types of gases, helium, hydrogen, oxygen, so forth.